Hi students, this video is about definite integrals. Here I have discussed some special sums so that you will be in a position to approach such sums very easily. Even though integration can be done in any method and it depends purely on the thought process of an individual, some special sums need special approach. Some methods are really very lengthy and complicated and also time consuming. So if you approach sums in a particular way, you'll be able to do the sums quickly and also correctly. Hope this video will help you do that. So this is the first sum. I is equal to integral 0 to a 1 by root of ax minus x square dx. So the first step will be to take the negative sign out. So open bracket, it will be x square minus ax inside. Now take the coefficient of x, which is a, leave alone the sign. Half of a will be a by 2, square of it will be a by 2 the whole square. So add and subtract a by 2 the whole square. So this will be the first step to do. The next step, take the positive square along with the x terms. So the first three terms look like a square minus 2ab plus b square. So how am I going to write it? It is just like a minus b the whole square, x in place of a and a by 2 in place of b. So it will be x minus a by 2 the whole square minus the last term as it is retained. Okay, so this is called completing the square method. So I have completed the square x minus a by 2 the whole square. Okay, so what will be the next step? It will be to multiply the negative sign with the terms. So I get root of a by 2 the whole square minus x minus a by 2 the whole square. Okay, so we are going to use sine inverse formula for this. So it will be sine inverse x minus a by 2 by a by 2. So be thorough with the formula, and then the limit is 0 to a. Okay, now so on simplification we get sine inverse 2x minus a by a, limit 0 to a. So let us apply the limits now. Sine inverse 2a minus a by a will give you 1 minus the lower limit. Sine inverse 0 minus a by a will give you minus 1. Okay, so sine inverse 1 minus of minus sine inverse 1. Okay, so now we get 2 sine inverse 1. What is sine inverse 1? Pi by 2. Yes, so it is 2 into pi by 2 and the final answer is pi for this sum. 0 to pi 1 by 5 plus 4 cos x. What is cos 2x? 1 minus tan square x by 1 plus tan square x. But here we have only cos x. In place of 2x actually we have x here. So if it is x on the left, we'll have half angle on the right, that is x by 2. So we'll have something like this, 1 minus tan square x by 2 by 1 plus tan square x by 2. So this is called half angle. Okay, so the next step will be to take common denominator, which is 1 plus tan square x by 2 here. So multiply that with 5, we get 5 plus 5 tan square x by 2, and then open the bracket, it will be 4 minus 4 tan square x by 2. So the denominator 1 plus tan square x by 2 can be taken to the numerator. There we have 1, so you can write this directly, 1 plus tan square x by 2 dx. Okay, now simplify the denominator, and the numerator can be written as secant square x by 2 using the second identity of trigonometry, which is 1 plus tan square x is secant square x. So now the denominator gives 9 plus tan square x by 2. So let us use substitution method. Take t as tan x by 2, so we get dt as half secant square x by 2 dx. Okay, so how the integral changes? It will be twice, this 2 is taken to the other side, that's it. Okay, it will be twice 0 to infinity, because we have to change the limit to the new variable. So as x takes 0, it will be tan 0 by 2, which is tan 0, 0, and as x takes pi, it will be tan pi by 2, which is infinity. So it will be 0 to infinity dt by 3 square plus t square. Okay, so that will be 2 by 3 tan inverse t by 3, applying tan inverse formula for this. So apply the limit now, it will be 2 by 3, upper limit minus lower limit. So it will be tan inverse infinity minus tan inverse 0. which is pi by 2 minus 0. On simplifying we get pi by 3. Okay. So let's do one more sum. Integral 0 to 1 by root 2 sin inverse x by 1 minus x square the whole power 3 by 2 dx. We'll take sin inverse x as theta. Okay. Here I would like to suggest something. See, the next step will be to differentiate so that dx can be replaced, isn't it? Instead of differentiating sin inverse x, let us take x as sin theta using inverse property. Okay. So that dx will be cos theta d theta. This will be much simpler than differentiating sin inverse x. Okay. So now let us change the limits to theta. So when x takes 0, so theta is 0. When x takes 1 by root 2, theta will be pi by 4. Okay. So how the integral changes? 0 to pi by 4, theta cos theta d theta in the numerator, and the denominator will be 1 minus sin square theta the whole power 3 by 2. Okay, let us simplify the denominator further using the first identity of trigonometry. It is cos square theta the whole power 3 by 2. So now simplifying the power, we get cos cube theta in the denominator. So theta cos theta by cos cube theta d theta. Okay, so let us cancel cos theta, and that will give us theta by cos square theta d theta. So reciprocal of cos theta is secant theta, so let us write it as theta secant square theta d theta. So it's a product of two functions now. So let's take the first function u as theta. Du will be d theta, and the rest of the integral secant square theta d theta as dv. On integrating, we get v is equal to tan theta. So coming to the integral, I is equal to, the formula will be uv minus integral v du. It will be easy for you to remember if you have it like this. Okay, it is uv minus integral v du. So theta tan theta minus integral tan theta d theta. Okay, the limit 0 to pi by 4. Okay, so what is integral tan theta d theta? It will be minus log cos theta. So already we have a negative sign outside the integral, so it is minus of minus log cos theta. Okay, so the next step will be theta tan theta plus log cos theta, limit 0 to pi by 4. So let us apply the limits now. Pi by 4 tan pi by 4, and then the lower limit is 0, just ignore, log cos pi by 4 minus log cos 0. So pi by 4 tan pi by 4 is 1 plus log 1 by root 2, cos pi by 4 is 1 by root 2 minus log 1, cos 0 is 1. Okay, yes. Now pi by 4 plus log a by b is log a minus log b. Using that, we write log 1 minus log root 2 minus log 1. You can cancel log 1 here, plus and minus. Pi by 4 minus log root 2. Root 2 can be written as 2 power half. Using power rule, we can write pi by 4 minus half log 2. So let's go for the summary. Step 1. Make the right substitution so that it simplifies the sum given. Step 2. Change the function as well as the differential in terms of the new variable. So if the original function is in x, when we make a substitution, we have to change x as well as dx. Okay. The whole integral should be in terms of the new variable. Step 3. Change the limits according to the substitution made. Step 4. Finally, integrate and substitute the limits. Simplify the final answer if possible. So these are the trigonometric identities that were used in the sums. So in the case of cos 2x, if it is 2x on the left, it will be x on the right for tan. If it is x, it will be x by 2. That's what I have done in the sums. Okay, that is called half angle. So whenever we use trigonometric identities or even algebraic identities, it is always better to mention whatever we have used in the sum on the right side. So one is presentability, the other is you'll be able to apply the identity correctly in your sum. Okay. Hope you have all understood the concepts and methods discussed in this video. Learn math the easy way. I have uploaded many concept-based videos and also math tricks in my channel. You can choose the topic from the playlist. Do watch all my videos and comment below in the comment section. Kindly subscribe and share it with your friends and classmates. Remember to press the bell icon to get notifications on new videos. Thanks for watching. Bye.